welcome to Chapter 5. This is the introduction to Chapter 5, and it will also include the lesson for 5.1. Chapter 5 is all about triangles and the Pythagorean theorem. However, we are going to really start with angles and do some review over some 7th grade concepts. So the first thing I want to have us do is, if you have not taken these notes, please draw the figure that you see at the right and label everything. You can pause the video if you need to anytime. Complementary and supplementary angles. Okay, that symbol up there is an angle symbol. A complementary angle, complementary angles add to 90 degrees. That's why it's kind of represented by the C that is in pink or red on the screen. And then supplementary is represented by the bottom part of the S. Supplementary angles sum or add to 180 degrees. In your notes, you should please be putting in the two examples down here below, the complementary example and the supplementary example. These two angles add to 90. These two angles add to 180, or they make up a straight line. These two make up a right angle. Okay. Again, you can pause the video at any time if you need to draw this into your math notebook. Angles around a point, I want to keep in mind that when we're measuring angles, we are talking about turns. We're not talking about lengths of sides or lengths of lines. We are talking about the space between lines, or the measurement degrees between two lines, or how far we would turn if we would take this line and move it around a point to this line. So that would be an 80-degree turn around this point. And if you go all the way around a point, it's 360 degrees. So all four of these angles add to 360. Okay. Over here, the same thing. If we were to take this side of this line and we were to move it all the way over to here, that would be a 180-degree turn. Okay. So a straight line is a measurement of a 180-degree turn to go from this side of the line to this side of the line. It's 180 degrees. And supplementary angles will always add to that 180. So if there's 150 degrees on this side of this yellow line, that means there's 30 degrees left on this side, because there has to be a total of 180. Okay? Now, if we had 30 on this side and 150 on this side, that would not make sense, because 30 degrees over here, okay, this is the larger part of the angle. So we need the larger measurement on the larger part of the angle. And the smaller measurement would go with the smaller part of the angle. Plus, this is an obtuse angle, and an obtuse angle is greater than 90 degrees. So 150 makes sense on this side, and 30 makes sense on this side. All right, the last thing we're going to review are vertical angles. Vertical angles are angles that are opposite each other when two lines cross. And vertical angles are also always congruent or equal. They are the same measurement. So there's the same degrees on this side as there is on the opposite angle, or the vertical angle over here. So if this angle is 40 degrees, angle B would also be 40 degrees. They are congruent. Okay, angle C and angle A are also vertical angles. They are opposite. And if angle C, if we knew the measurement of angle C, we could figure out the measurement of angle A. I do believe we can figure out the measure of angle C. Here is a straight line. Here are two angles that are on this straight line. We know this part of the 180 is taken up, and it's 40 degrees. So if the whole entire thing is 180 and we have 40 degrees taken up, that leaves 140 degrees for this section here. So if this one is 140, then angle A is also, the measure of angle A is also 140. All right, now we're getting into exactly what we're learning for this section, 5.1. It's about parallel lines, transversals, and angles. So draw this picture right here into your notebook, and the first thing I want to identify is that L and M are the parallel lines. N is what is called the transversal. Kind of like the transcontinental railroad cuts across the entire United States, transcontinental, across the continent. A transversal is a line that cuts across these parallel lines. Okay, so N is our transversal, and then it creates 8 different angles. 4 in this intersection, and then 4 more in this intersection, okay? And then we're going to focus on interior angles first. The word interior means inside, so we're going to focus on the angles that are inside those parallel lines, 3, 4, 5, and 6. These are our interior angles. And make sure you get those written down. Our exterior angles, well, exterior means outside. So our exterior angles are outside of the parallel lines. So there are 2 that are up here, angles 1 and 2, that are outside. And then 7 and 8 are also outside. So interior angles, and then 1, 2, 7, 8, exterior angles. Okay, we're going to add a word to this. It's the same picture. We haven't changed the picture, but we're just going to add a word to this. We're going to start, first of all, with our interior angle. So focus here on interior, which means we're still looking at 3, 4, 5, and 6. We're still looking at these 4 that are inside the parallel lines. Okay, but now we're adding this word alternate. Well, the word alternate can mean lots of things. In this case, it means opposite. Okay, alternates like take turns, opposite, the alternate person, okay, an alternate reality, okay, it's the opposite. So I want to look at these. We have 2 pairs of alternate or opposite interior or inside angles. So opposite, inside. So again, focus on our interior angles. And now we're going to look at the pairs. And I'm going to explain to you what I mean by opposite. So let's start with angle 4. Here we are. We're starting right here with angle 4. And here's angle 4. Okay, so we want to find the exact opposite angle. So we have to not only go opposite on the opposite side of the transversal, we have to go on the opposite side of the parallel lines themselves. So 4 is at the top parallel line, and angle 5 is across the transversal and on the bottom parallel line. So we go opposite, opposite. And 4 and 5 are alternate interior angles. Okay, let's look at angle 3. So angle 3 is here. So while it's an interior angle, we need to go opposite, opposite. So 3 and 6, they're opposite in every way. They're still inside, but they're across this and down here. Okay? Okay, now moving on to alternate exterior angles. Well, we have the same word alternate in there, but this time we're going to focus on the outside angles. So we're going to focus on 1, 2, 7, and 8. Okay, however, the alternate part is the same. So let's look at our pairs of alternate exterior angles, angle 1 and angle 8. So let's go up and look at angle 1. Okay, here's angle 1 right up here on the left. So we're going to go across the transversal and across the parallel lines. So opposite, opposite. So angle 1, angle 8, alternate exterior. Okay, now angle 2 and angle 7. So same thing. Angle 2 is on the right, so we're going to go opposite, opposite. So angle 7 is on the left and on the bottom. It's very opposite of angle 2. The reason that these 2 types of angles are important to know is because they're congruent. So alternate interior are congruent and alternate exterior are congruent. So let's go back and look at these. Angle 4 and angle 5. And look, angle 4 and 5 are both obtuse angles, and 3 and 6 are congruent, and they're both acute angles. Same thing up here, angle 1 and angle 8, they're congruent and they're obtuse, and angle 2 and 7 are congruent and they're acute. That's the importance of these angles. So you know that if you have 2 parallel lines cut by a transversal, angle 1 and angle 8 are going to be congruent, and all the other sets too. Okay, the last thing we're going to learn, the last section of this, is corresponding angles. Okay, same picture, but remember how I said this was like an intersection here at the top, and this is an intersection here at the bottom. Well, corresponding angles have to do with the intersection. Corresponding angles are the angles that are in the same position, I'm going to say, in the intersection. Okay, so in relation to the transversal and the parallel line. So if we took this intersection, if we cut this intersection out and we slid it down to this intersection, angle 1 would lay directly on top of angle 5. Angle 1 and angle 5 are corresponding. I would take this intersection, slide it down, and lay it on top. 1 and 5 would correspond, just like right here. 2 and 6 would correspond. 3 and 7 would correspond, and 4 and 8 would correspond. You can kind of look at it like road intersections, and this would be the northwest corner, and this is the northwest corner. And this is the northeast corner, and this is the northeast corner. So they kind of have the corresponding places in the intersection. They are also congruent. That's the importance of them, is they are congruent. So we know that 1 and 5 are congruent, and we know that 5 and 4 are congruent, and we know that 5 and 8 are congruent because they're vertical. So every obtuse angle in these 8 angles are equal. And every acute angle, 2, 3, 6, and 7, every acute angle, they are also equal. So I'm going to send you to the next slide, and I would like you to stop the video and do these 3 problems, and that'll be the end of 5.1 of what we're doing, or what we have did today in class. So we're going to classify. Now I want to point out that these 2 lines, our parallel lines, are now going up and down. So instead of going right to left, they're going up and down. So, oops, sorry, I went back. So our interior angles are now inside here. They're sandwiched in between this direction. So 1, 4, 5, and 7 are now our interior. 2, 3, 6, and this one that's 135 is now our exterior angles. So I want you to classify. I want you to look at 1 and 7. And I want you to classify whether they're alternate interior, alternate exterior, or corresponding. And do that for all 3 problems. And then you're done.